Lesson 7 in Chapter 9, Special Functions. And I'm going to be honest with you, I've never actually seen these functions before. That doesn't make them hard, it just makes them new to me. All right, so I saw these brackets and I thought, what in the world do they mean? Okay, so they are a step function. So that's a series of line segments. This is an awesome picture right here. And one of the circles is filled in, so it's equal to, and then the other one is open because you can't have it filled in both spots, okay? It's going to be disjointed line segments. The domain is always going to be all real numbers, and in this case, the range, if you look all the y values, do you see how there's never any spots between because it has to be an integer? This specific notation represents the greatest integer function, so that means the f of x, or the function, is equal to the greatest integer that is not greater than x. So, for example, if you take the brackets of 6.8, that is going to be equal to the biggest integer that is not bigger than 6.8. So the greatest integer prior to that would be 6, up until 6.81, 6.82, 6.89. That all will be down. You round it down to 6. The only way it's equal to 7 is if it is 7. Okay, so we can add to that. Take a look at this function down here. In example 1, they have the greatest integer function, but then they add a 3 to it. So let's think about this. And you can put in whatever numbers you'd like. So I'm going to put in, I've got some numbers in here we can put in there. So the greatest integer not greater than would simply be -1. Right? Then negative, now think number line, -0.5 isn't as big as 0 as we go left to right, so the greatest integer would be -1. 0 would be 0, all right? 0.25 would have to be 0. 0.5, you got to round down to 0. Once you hit 1, you're good. But if you go a little bit above 1, we got to go back down to the integers. So it's always going to be integers. Okay, so we found that value. Now we just add 3 to it to find the actual value of the function. So -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. So if I'm graphing these, what it ends up looking like, okay, so -1 for x, which is right here, is actually equal to 2 for y. Now, even, as we move forward, it's all going to be equal to 2 until you get to 0. The value for 0 is actually 3. And then all the numbers up until we hit 1 would be equal to 3. All the number, and then 1 would be 4, and all the numbers, and then I can just sort of fill out this pattern as we go. Right here. This is an open one. This is a closed one. This is an open one. This is a closed one. All right? So that's what it looks like. So your domain, you can plug anything in. So that's all real numbers. But your range is all integers. All right? So that is a step function. So how does that relate to real world situations? This is a really great example of the real world situation. It actually is what made sense to me after I looked at it. Okay, so a painting. If you hire a painter charges $15 per half hour, or any fraction of a half hour. So, and oftentimes that's how the real world works. Even if you go for 45 minutes, they're going to charge you for the first half hour, plus they're going to add another half hour, even though you didn't fill it up. Okay, so if x is, so say x is 0.1 of an hour. Well, guess what? They're going to round it up to a half hour, which is going to be $15. So they're going to round it up, and it's going to be $15. Okay? If you work 0.5 hours, it's still $15. But if you go a little bit above that, just even 0.6 hours, they're going to round it up to another 30. 0.75 hours, still 30. Once you hit 1 hour, they're going to charge you they're still going to charge you $30. But when you go over 1, so like 1.25, they're going to charge you 45. Up until 1.5, still going to charge you 45. But you hit, you hit 1.75, then it's going to jump to $60. So if I'm looking at this, so even if you show up for a little bit, it's going to be, so we got an open circle here, because they're not going to charge you for 0, but everything after 0 up to a half hour is going to be $15. Then add anything onto that, and it's going to charge you $30 up to 1. Add anything onto that, 45. Add anything onto that, 60. So this one's kind of different because you're rounding up. Remember, in the greatest integer, we rounded down. So take a look. We got open circle and then the closed circle down there because we rounded down. But, you know, in real life, they don't hardly ever round down. They round up. So you keep doing that. Filling it out. Open circle, filled circle. Open circle, filled circle. Open circle, filled circle. So again, if I were giving my, my range, my domain would be all real positives, all positive numbers, because, you know, time in terms of painting is always going to be positive, but it could be any amount of fractions. But your range is going to be multiples of 15, because they're always going to round up to the next $15. Okay, so let's flip that page over. That was greatest integer function and what this notation looks like with the double brackets. All right. Okay, something so we've talked about before, absolute value. Remember, absolute value can never be negative. The absolute value function is always going to be positive. So whether I put in a -5 or a +5, it's going to end up being the positive value. So the parent function for the absolute value is this, because 0 is 0, but 1 is 1, -1 is 1, because you're always going absolute value. So this is what the parent function looks like. So if x is less than 0, it's going to go like this. If x is equal to 0, it's going to equal 0. And if x is less than 0, greater than, less than, you got it. Okay, so it is V-shaped, and we can actually use our information that we learned about parabolas and how parabolas change based on our, our equation. If you remember our equation, it looked like this: y equals a parentheses x minus h squared plus k. You can relate this to the absolute value function. So if you have something like f of x equals the absolute value of x minus 3 plus 2, well, guess what? That's going to go right 3 and up 2. And it will move that v to right here. Okay, kind of cool. This is a piecewise function because it's defined by two different rules, if you will. A rule for negative x's and a rule for positive x's. There are two rules. So let's look at this right here. Okay, state the domain and range. Start by setting the function equal to 0, which it already is. Now I'm going to plug numbers in there. So let's go 0, -1, -2, -3, and then 1, 2, 3, just to plug it in there. 0 plus 2 is 2, absolute value of that. -1 plus 2 is 1, absolute value of that. -2 plus 2 is 0. -3 plus 2 is -1, but we take the absolute value. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 3 is 6. 3 plus 2 is 5. My bad. All right, maybe just some more negatives. How about a -4? A -4 plus 2 would be -2, but it's positive. And -5 plus 2 would be -3, but it's positive. So let's see. -2, 0. -1, 1, 0, 2. 1 is going to be 3. 2 is going to be 4. 4 is going to be 5, and so on and so forth. And on the other side, -3 is 1. Negative 4 is 2, 2, and negative 5 would be 3, and so on. So this is what it looks like. And notice this would be my x minus a negative 2. So it is going to the left 2. Do you see how it is shifted? Now the domain is still going to be all real numbers, because I could plug decimals into that equation. It'd be fine. And then the range is going to be any of the y values. Well, because it's absolute value, will it ever be negative? No, it will not. So y has to be greater than or equal to 0 for this particular function. All right, so moving on, let's talk about another one of these, a piecewise function. A piecewise function just means it's breaking it down for the different values of your domain, x. So you would graph a line that follows this. So start at positive 3 and goes up 1 and over 2 if x is greater than or equal to negative 2. All right, so greater than or equal to negative 2. But if x is less than negative 2, it's a totally different line with a y-intercept of negative 5 and a slope of negative 1. So we could plot these, all right, x and y, if you need to. Okay, so if I put in, say, negative 4, negative 3, negative 2, that would be x is less than. So if I put in negative 4, it's negative 4 minus 5. So it's a positive 4 minus 5 would be negative 1. If I put in negative 3, that would be negative 2. If I put in negative 2, I change my equation. It changes. It's going to be x is 1/2 times negative 2 plus 3, which would be negative 1 plus 3. That's going to be 2. If I put in negative 1, well, that's going to be negative 1/2 plus 3. That's going to be 2 1/2. All right, so let's just plot these. Negative 4, negative 1. Negative 4, negative 1. Negative 3, negative 2. So, but negative 2 goes up to 2. And that's equal. Negative 1 goes up to 2 1/2. If I put 0 in there, I will get 3. So because this can never go below, it's going to look like that. But here, this can go all the way to 2. But it has to be greater than 2, and this is where x equals 2 right here. So it's an open circle because it sets the boundary. So we have two different lines. It's a piecewise function. There are two pieces to the function. Kind of cool. Okay, domain, still all real numbers. Okay, but range, if we think about the values of y, this one goes up this direction, this one goes up that direction. So all these values from this point on, not here because that's an open circle. So y is just greater than negative 3. All right, moving on, then we just got some study tips. So here are the 3 things we talked about. We got the step function, the absolute value function, which is going to be a v, and then the piecewise, which we just talked about up here, something like that. All right, so where am I at? I gotta flip my paper over. No, actually we're done. Haha. So your assignment is connected to your ivory notes. You will need some graphing paper. I'm not exactly sure how many, so double check. You have them available, so let's see, you need to graph 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. So there's your assignment. If you have any questions, I know this is kind of new. If you have any questions, please come in and see me. Good luck.